All right, so let's talk about vector multiplication. Let's talk about the dot product. All right, so the dot product is kind of a way of multiplying two vectors together, and so I'll explain all of this in a minute, but first rule is that the inner dimensions must be equivalent. Okay, the outer dimensions must be 1. This particular product is also known as the inner product or the scalar product. So what this means is that we have to have a row vector times a column vector in order for the dot product to work. It has to be a row vector times a column vector. Okay, so we have these two vectors here, right? Both of them are column vectors because that's how we write it. So vector B and vector C. They're both n by 1, which means what I can't do B times C or C times B because those break the rules. But I can do B transpose times C, right? Where B transpose is a row vector and C is a column vector. And so when you transpose B, it's a 1 by n, whereas C is an n by 1. So the outer dimensions are 1, the inner dimensions are both n. They're equivalent. That's how you have to do it. So what does that mean? Well, in order to do it, you take the first element of each vector and you multiply it together. Then you add the second element of each vector, you multiply those two together. And you do that on and on to the very last one. And then you sum up all of those, and that's your dot product. It's called the scalar product sometimes because it returns a scalar, just a single number. And in fact, you can actually write it with summation notation, which if you're not familiar with summation notation, I encourage you to go watch our video about it. But basically, right, this is the sum as I goes from 1 to n, whatever the length of your vectors is, of bi times ci. And that is an element of 1 by 1. It's a single number. So let's look at an example, right? So if you have vector b, 6, 2, 5, 3, and vector c, 3, 7, negative 2, 3. In order to do the dot product, right, the first one has to be transposed. So b transpose c, right? The sum as I goes from 1 to n of bi, ci. So let's do it. b1 is 6, c1 is 3. So 6 times 3 plus 2 times 7 plus 5 times negative 2 plus 3 times 3. And I kind of like to write it like this. It's an element of R 1 by 4 by 4 by 1. Right? You write out the whole 4 dimensions, and then those inner two cancel out, and you only keep the outer ones. All right? So it's going to be a 1 by 1. And if we do the math, right, 18, 14, negative 10, 9, your total gets you to 31. So B transpose times C for this example is 31. Like I said, just a single number. Sometimes I like to think of it kind of like you're zippering the two vectors together, and you kind of just zipper them and then take the sum, and there you go. All right, that's the dot product. Hopefully that wasn't too bad for you. Tune in to the matrix multiplication video where we'll learn where the dot product becomes really, really useful and important. Thanks for watching. See you next time.